I've only been doing this for a few years. Okay. 3, 4. Hello, everyone. Welcome to our February RAS public talk here today at Burlington House in Piccadilly, London. My name is Lucinda Offer. I'm the Education Outreach Officer and very happy to welcome a studio audience today. Thank you for being with us, and also those who are visiting us on Zoom. So thank you for there will be Q&A. So if you're on Zoom, you can use the Q&A icon to put in any questions you have for our speaker today. And if you're on Zoom, there is the Q&A chat is opened for your questions. If you're not a member of the RAS channel, I do believe you have to be subscribed to the RAS YouTube channel to be able to post any questions. So please do that. I think it gives you a 5-minute waiting time before you can post a question. So just giving you a heads up. But I'm very happy to be here. I first met Catherine at one of our RAS Reach events. I think it was in Newcastle. Yeah, and she had just gotten funded for her Eyes on Mars work and project. And of course, we know we don't know yet the actual fate of ExoMars. Fingers crossed that it's all going to continue to go forward. But we've all been through a lot since then, since I last saw you. And I'm so happy to have her with us today. So she's going to talk about Eyes on Mars, increasing awareness of UK Mars exploration. And I've been working in Mars human space exploration for 20 years. So I'm really excited to hear her talk. So again, this is Catherine Regan. She's a final year PhD student at the Mullard Space Science Laboratory, MSSL, at the University College London. She researches how global scale dust storms at Mars influence the induced magnetosphere using data. I'm just going to make sure we are on audio, yes. Using data from ESA's Mars Express and NASA's MAVEN satellites. Alongside her work, she is heavily involved in outreach and science communication, and she was the first chair of MSSL's Outreach Working Group and is currently the vice chair of the Science and Technology Facilities Council's Public Engagement for Early Careers Forum. Coming from a non-traditional background to studying space, she is passionate about encouraging young people to pursue STEM subjects. Catherine has won multiple awards for her outreach work, including one for this project, Eyes on Mars. Please welcome Catherine Regan.
Thank you so much for coming, and thank you for that great introduction. I can skip a few of my slides now because I talk about that a little bit more. But I'm here to talk about raising awareness of my project, Eyes on Mars, which is working on Mars exploration. Hopefully the slides will appear.
That's my fault. I think let's try that one.
There we go. Fantastic. Nothing like technical difficulty. So I'm going to be talking about Eyes on Mars, and this project has been funded by the Science and Technologies Facilities Council, which is part of the UK Research Institute and the Royal Astronomical Society. So they have funded this work, but we have been supported by multiple institutes around the UK. And I'll be talking a little bit more about the support we've been given and what we've done with that support as we go forward. Hopefully,
it's on as well. It's not.
Just move this as well. There we go. Okay, fab. So I'm a PhD student at the Mullard Space Science Laboratory. That's already been said. So I am in my final year, well, in my final few months. I'll be submitting my thesis soon. And the Mullard Space Science Laboratory is part of University College London, but we're quite unique in that we're not based here in central London. We're actually based in the Surrey countryside, which makes us a beautiful destination to come visit, but a bit out of the way. And here I'm studying the influence of global dust storms. So I'm heavily involved in Mars exploration at the moment, working with the Mars Express and the MAVEN satellites. That's what I do in my kind of day job. But to get here, I had a bit of a, not rough, but a difficult start when I was at school. I wasn't in top set science, and I was told I wasn't clever enough to do physics. So for a long time, I believed this was the case. I didn't think that I was good enough to do science, good enough to pursue science as a career. So I went in the kind of geography route. I focused on volcanoes. And then from studying volcanoes and earthquakes and earth sciences at university, I realized I could apply this to other planets, started studying volcanoes on Mars, and the rest is history. And I'm now here doing a Mars PhD. So because I've come from a non-traditional background of not studying physics or astrophysics at university, I'm very passionate about encouraging people to do space and to do STEM-based subjects, even if they believe they're not clever enough or don't have the kind of background knowledge to do it. The really good thing about space is it can be applied to any subject, any area, not just science as well. So that's something that I'm really passionate about involving in my work. Now, it was already been mentioned, but I was the first chair of MSSL's outreach working group. So this was made just after COVID to make sure the department is really kind of encouraging and pushing our outreach and public engagement programme. So we've been able to do a number of open evenings and do online events. And this is kind of now going forward into the department to kind of stay in the next few years, which is really good. And I'm vice chair of the STFC's Peer Forum. So there's a lot of acronyms there. So it's the Science and Technology Facilities Council, Public Engagement for Early Career Researchers Forum, lots of letters. But we are kind of a nationwide group of early career researchers that come together to talk about how in the UK we can improve public engagement for researchers, which is a fantastic thing to be involved with. And a few more credentials. I've given multiple talks to schools, youth groups, astronomical societies. I've done radio interviews. So I'm not just kind of involved in one area of public engagement. I've kind of spread myself out and do lots of things across lots of different places. So hopefully that's kind of given you my CV to prove that I'm the person to be talking to you today about this. So what's the inspiration behind Eyes on Mars? Why did I begin this project and what's this project about? So I started my PhD in lockdown in 2020, and while I was remote, I learned about all of the fantastic involvement the UK has in Mars exploration, in particular at the Mullard Space Science Laboratory. We're heavily involved in Mars, and when I learned about this, I thought, this is fantastic. Why am I just hearing about this? This needs to be shouted and spread from the rooftops. So I really wanted to spread this excitement and encourage particularly young people to aspire to do space as a career option. So myself and my colleague, Priya Patel, who's in this photograph, had lots of conversations about what kind of things can we do from COVID. We were also having this conversation across the pond. She was in America, I was here, and we were trying to kind of come up with a concept that we could do ourselves to get other people excited about what we're doing. So this was the concept of Eyes on Mars. We came up with Eyes on Mars and we applied for different funding, and we got awarded funding by STFC through their Sparks Award and also through the Royal Astronomical Society's Outreach Award as well. So that's how we've managed to fund this project and been able to do it alongside our PhDs. So what actually is Eyes on Mars? We're a public engagement project and we provide educational resources based on the UK involvement on the camera on the Rosalind Franklin rover. And how have we done this? We've done this through two ways: a social media platform, which I'll start off by talking about, and then the main way, which is our free activity resources. But in order to be able to talk about what we do, I first need to introduce you to the Rosalind Franklin rover, or it was previously known as the ExoMars rover, but now she is Rosalind Franklin. So this is a European Space Agency mission, and it will be launching in 2028, fingers crossed. We unfortunately have had quite a few delays due to technical issues, geopolitics, but 2028 is currently the launch date. And on board, there are 7 different scientific instruments, so 7 science experiments, including a 2-meter drill. Now, all of these experiments are really exciting, but the 2-meter drill in particular is nice because it's the deepest anyone will have ever gone into the surface of Mars. So Perseverance, which is there at the moment, NASA's flagship, only goes kind of 6 to 7 centimeters. So we're going well below the depths. So we're going where no human has gone before, which is very exciting. And this rover was actually assembled in Stevenage at Airbus here in the UK. So this is kind of a really big thing for us in the UK. We built the rover. We got all the different instruments from across Europe to come together, and it was built in Stevenage. But what I'm really excited about is the camera. So this is what's on top of the mast, and this is built and led and was designed and tested by scientists and engineers in the UK. So this is the inspiration behind the project. And if you hadn't guessed, this is built and led by the Mullard Space Science Laboratory, where I'm doing my PhD. So this is the rover, should be going in about 4 years. But why is it called Rosalind Franklin? So Rosalind Franklin was the winning entry by a competition the European Space Agency ran. There were entries like Rover McRoverface, but there were thousands, and this was the winning entry. And this is fantastic because Rosalind was a British scientist. She worked in London and she was most known for her X-ray work. So she did a lot of X-ray work and scientific investigations during the war. And then post-World War II, she applied this to DNA and DNA imaging. And she was the person that was kind of credited to take the first photograph of DNA. So we now know that DNA has got this double helix structure, and this is all because of Rosalind's work. Now, Watson and Crick are the people that are normally credited for this work. Now, they took Rosalind's kind of foundations and their work and then built the double helix DNA model. They won the Nobel Prize. They got lots of awards and accolades, but didn't credit her anywhere. Now, this is because even though it was 100 years ago, less than, female scientists weren't seen as being as good, which is ridiculous. But thankfully now we know all of the amazing work that she's done, and we can credit her. And she's had buildings and awards. I think she's had a comet or a meteor named after her. And the latest thing is the rover, the Rosalind Franklin rover. Now, unfortunately, she didn't live long enough to kind of see her work and see her successes. She died very young at 37 of ovarian cancer. But now there's a lot of work done to honour her memory, and this rover is the latest thing. So that's the rover. Now I'm going to talk a lot about the camera on top. So it's called PanCam because we love an acronym in space. So the acronym stands for Panoramic Camera, and this sits at the very top. So this is not up-to-date version of the rover. It is slightly different now. We've got a few more British instruments going on it. But the camera is at the top, and you can see it kind of looking down, imitating what it's going to be doing on the surface of Mars. So this was designed, built, tested, and is led by the Mullard Space Science Laboratory, part of University College London. So here's two of our engineers handling the actual hardware going into the real PanCam, which is now on the rover. And it's composed of 3 individual cameras. So it's one kind of body, but 3 cameras on board. So there are 2 wide-angle cameras. These are the 2 circles at either end, and we call them WACs. And then there is a high-resolution camera, which is the larger circle in the middle. So between the 3 of them, they'll be able to take some really nice panoramas, some really nice high-resolution images, and be able to take photographs and see what we're looking at on Mars. Now, what's quite neat about these wide-angle cameras, or our WACs, is they contain a filter wheel. So at each end, there are 11 different filter wheels, so 22 in total, and each filter has been designed to look at different aspects of the Martian environment. So say, for example, we're looking at a scene on Mars, we can put a certain filter on it and it'll highlight different things. So if we want to look at the sunset, if we want to look at how the sunlight is reaching the surface, we can put a certain filter on to take that photograph. Or if you want to look at the clouds and look at the water vapor, we can put a different filter on and that will highlight those to us. So from looking at one scene, we can take multiple photographs with lots of different filters to be able to do loads of different science. So this is super exciting. This was designed in our department, and these now sit in the 2 WACs in the camera, which is great. So this is the science inspiration of this project. Originally, I was meant to be working on this for my PhD, but unfortunately the mission got delayed, so it hasn't gone. So that's why I ended up doing dust storms. But just learning about this when I started was what wanted me to make the project Eyes on Mars, to be able to talk about this and educate those around the UK about the amazing science and engineering that we're doing. Okay, so the first kind of arrow, the first aspect of how I've done this is through our social media platform. So I've just put the handles of our social media up here. So we've got our Facebook, our X or Twitter, YouTube and Instagram. So we chose these aspects because these are social media platforms I'm familiar with. A few people asked if I wanted to do a TikTok channel, but actually I feel like I'm too old for that now. I wouldn't know how to approach that, which I never thought I would say. I'm too old for a certain type of social media, but that's why we went for these platforms. And we felt like with these as well, we're kind of reaching a broad range of audience levels, different ages, different demographics. And basically we can do kind of short, snappy posts. So it's not, people aren't going to have to read long articles or long essays. We can disseminate information in kind of nice, small ways for people to be able to absorb. So these are also on the bottom of all of the slides. So if you want to give any of them a follow, then please do. But here's an example of some of the posts that we've done. So we've led kind of different campaigns as well as general posts advertising our project. The one in the middle is our part of our campaign where we took a lot of science terminology that for scientists is kind of used in everyday conversations. We're very familiar with this terminology, but the public might not be. So spectroscopy is something that is used for quite a lot of the instruments on board the ExoMars rover on Rosalind Franklin. So we've kind of taken words like this and broken them down and said, what do we actually mean by these words? So we did a campaign for lots of different terminologies. And then also on the right, we did a campaign about space careers and what different space careers you can do if you haven't got a physics or astrophysics background. So that's where I've come from. And I wasn't aware of the kind of broad variety of space careers that you can do. So it's not just science. We also have policy, communications, journalism, law. Space law is a very big thing at the moment. Who owns the rights to space? If you bring back samples, who owns them? So there are so many different applications for space and space type careers that you can do. So that's what we wanted to get across with these kind of campaigns on our social media. And they seem to have gone quite well. Social media kind of evaluation is something that I'm not familiar with, so I've done what I can with it. But the social media branding and our logoing has been really strong throughout, and I believe it has been quite successful. So I'm very proud of our social media side. Now, something we also did in our social media, which is now available on our YouTube channel as well, is an interview series. So at the beginning of the project, the ExoMars mission was meant to be launching in September 2022. So we had applied for funding to be able to go and interview scientists and engineers around the country to talk about their involvement in the mission, their involvement in PanCam and their career paths. So we started off at MSSL, where I work, and we interviewed myself, Dr. Louisa Preston, who's an astrobiologist, and Barry Whiteside, who's on the screen, who's an electronic engineer. And we interviewed and got great content about their involvement in Mars, how they got involved, what their favourite facts are, and what their day-to-day life is like. Now, unfortunately, the day we recorded these interviews was the day the mission got suspended. So we had just finished recording, we were very excited to start editing, and the press release went out that the rover was suspended because of the Russian invasion of Ukraine. So geopolitics is not something that I expected to be involved in my project at all, but unfortunately it was. So the wider interview series across the UK got cancelled. So we now only have interviews from MSSL, which is a shame, but it meant that we could apply our resources to other things. But that was the first kind of lesson learned, is expect the unexpected. Who can predict that geopolitics would affect a little project like mine? So that's our social media platform. But now I want to talk about the kind of real star, which is our filter wheel activity. So going back to this image of PanCam and our filter wheels, this is kind of about that big. Hopefully you can see on the camera, about that big. They're very, very small, these filter wheels. And we thought, how can we get this types of science and engineering into the classroom? So we had lots of different mock-ups, lots of different ideas and sketches, and we came up with this, a cardboard filter wheel. So we managed to create, with 2 bits of card and some coloured cellophane, this is actually prototype number 1, where we use quality street wrappers to create your own version of the filter wheel that is inside PanCam. And this is class number 1, so test number 1, a school down in Surrey. So we created this activity where you can create your own filter wheel based just like the one in PanCam, so your own eyes on Mars. So we created this project, and we also created a ton of activities that you can do once you have your final filter wheel. So what do we provide? We've got funding, which means that we are able to provide all of the resources that are needed to be able to do this activity. So we send physical packs, physical boxes with all of this stuff in. So it provides the craft materials, which involves the coloured cellophane, the split pins, because those are things that kind of not all classrooms will be able to have in their kind of arts and crafts cupboard. So we provide those, we provide templates, we provide stickers. So stickers are available for every student. They get 3 stickers, which is the best incentive you can imagine. And for those of you that are lucky to be in the room, we have some of those stickers on the tables, so you can take home some of your own stickers. And then also a thank you postcard for the teacher with information on how to give us feedback, instructions for them, and lots of other information. And the last bullet point on here is that we also provide OCA, which is Ovarian Cancer Action Symptom Card. Now, this is a symptom card that we provide for the teacher. This is not to be distributed to the children, although they can talk about it if they want. But this is for the teacher or demonstrators to raise awareness of the symptoms of ovarian cancer. Now, this is a partnership we've got with Ovarian Cancer Action. So they provided these resources for us free of charge to be able to distribute to schools across the country. So why have we got this partnership? We've got this partnership because Rosalind Franklin died very young of ovarian cancer at age 37. So they've done quite a few blogs and articles when the Rosalind Franklin naming was announced. They did quite a lot of press about Rosalind Franklin and the fact that she had ovarian cancer. And I also personally have a lot to do with Ovarian Cancer Action because my mum died of undiagnosed ovarian cancer when she was 54 over 11 years ago. So she displayed all of the symptoms, they were completely missed, and she was only diagnosed after she died. So I personally do a lot of fundraising for Ovarian Cancer Action. So once the conversation was had that I'm creating this project about the rover, they said, let's collaborate. So we've been able to distribute information about ovarian cancer to over 150 people, which we're really, really happy with. So those are the physical resources that we've been able to distribute across the country. But alongside that, we're also sending digital resources. So we not only send the pack, we also send an email with lots of resources as well. And this includes the copies of everything we send them physically, the risk assessment, that's the boring stuff that we have to do because our activity involves scissors and glue. But also we have the lesson plan, the PowerPoint presentation, worksheets and activities and videos. So basically, if teachers want to do our resource, they don't have to do anything other than download it. We have provided everything for them to be able to do this in their classroom. Now, it's aimed at ages 7 to 13. In years 5 and 6, they do space and the science curriculum. And they also do light and how light travels into our eyes and colours and absorption. Then it also fits into the curriculum for years 7 and 8 as well at high school. So we provided everything. We've also made some fancy videos, which I'm not going to play, but are on the side and are available on our YouTube channel, where we do the step-by-step instructions. It's very Blue Peter. Here's one I made earlier. So they can follow step-by-step and know exactly what they need to do in the classroom so they can make their own filter wheel. And we provide resources so every single student in their class is able to make one and take it home. So they're able to take it home, then go and talk to their parents or carers and talk about the science and engineering. So the knowledge goes forward outside the classroom as well. So the worksheets and activities we've made link in with the filter wheel, but they also we have a worksheet about maths, so about how you can use maths in space and how we use maths for Mars exploration. But my favourite one is the filter wheel activity. So hope this a big file, hopefully. Here we go. So this is a real life photograph of the surface of Mars taken by Curiosity, one of NASA's rovers, and all over, I'm not sure, hopefully you'll be able to see it well online and in the room, but we have hidden Rosalind Franklin's across the surface in different colours. So the idea is with their finished filter wheel, they can look at this image in different colours and some rovers will appear, some will disappear, and some will stand out, some will look a bit hazy. And it's all about understanding why that is, why looking through different colours can give us different information and how that will work on Mars. With our filter wheel in PanCam, we can take different information from photographs and be able to do science with it. So that's the activity. Okay. There we go. Okay, so the numbers reached. I'm really proud of this slide. So that is our geographical distribution. When we first started doing this, the southeast was where all of the kind of red pointers are, just because we're based in Surrey. So I was able to go and reach a lot in Surrey, but now we've kind of gone across the UK, lots in Scotland and in Wales, but there are still a few gaps that I want to try and reach. But we've had over 4,600 participants. So these are 4,600 filter wheels that have been made by students across the UK, which I'm really, really pleased with. Now, we specifically target low-income schools. So we don't provide these resources physically for private or fee-paying schools. We send them the digital resources, but we ask them to pay for the materials themselves because we really want to reach the schools that wouldn't have opportunities like this normally. So myself, I've delivered this in person to 10 schools. Now this geographically is limited to the Surrey area, just based on where I live, but I've been able to go and do that in person. So this is a photograph of me doing it to a school in Dorking, which went really well. And I'm actually holding one of the models of the camera there, so you can see it for a kind of size scale. And what we've also been able to do is we've partnered up with the STEM Ambassador Programme. So I delivered some online training for STEM ambassadors, and the STEM Ambassador Programme is where you can volunteer if you're a STEM professional or student to give your time to do outreach and public engagement. So I trained up some STEM ambassadors to be able to go and deliver this project. So they request the resources from me and then they go and distribute it themselves. So again, it's taking the kind of time away from the teachers. They go into the schools themselves and deliver it. So this has been done about 15 to 20 times by STEM ambassadors, which we're really, really pleased with. Now, we've also been able to distribute it through a few other ways that were kind of not expected when we initially planned this project. And the first one is through a project called STEAM Packs. So I've added the Twitter for the STEAM Pack team by a student called Annabelle, who is lovely. And she heard about the project and got in touch, and her mum wanted to get involved with Eyes on Mars and find out what they could do. So what I did was I made up 250 individual packs. This is for 250 students, and distributed these to them, and they sent them to children that are chronically or terminally ill in hospitals, so can't attend mainstream school, so attend schooling in hospitals. So they were able to distribute them, which I was really happy with because I wasn't planning that in my initial proposal. So I was really pleased with that. We've also been involved in Mars Day. So this is something that has been created by UK ESRO. So Mars Day happens in March. The next Mars Day is on the 5th of March. So for last year, we sent about kind of 200 packs out to schools where they could create their own filter wheel, where everyone across the UK involved in Mars Day was doing it at the exact same time. So it's a really good event. I'd really recommend signing up to it. They've got tons of talks and panels, and also you can take part in Eyes on Mars. So we will also be advertising to take part in Mars Day again this year. So these were two things we weren't expecting to be able to get involved in. Something else we were able to do, now this was actually funded by the UK ESRO team, as we managed to go to New Scientist Live, which happened at the ExCeL Arena in October. This is 3 days of just science kind of mania in London. It is fantastic. It's every type of science you can think of. There's exhibitions, there's talks, there's panels, and right under the giant Mars exhibit, there had an Eyes on Mars stand. So we reached kind of thousands of students that were there, and they made tons of filter wheels. There was cellophane everywhere. You can imagine the mess, but it was great fun. And we also appeared on the front of the New Scientist website, which I was not expecting. So that was really successful for us. And then a bit on the smaller scale, but the Mullard Space Science Laboratory had a summer open day this year, the first time in a long time. And in the kids' activity tent, we had an Eyes on Mars stand as well, which was hugely popular. So we had loads of people, about kind of a few hundred children coming and staying with us for the whole day. I think the parents thought that it was great. They could just leave their child with us while they explored. So we did become a bit of a kind of nursery, but it was fine. So we had lots of people making filter wheels, and this image in the middle is one of my favourites. This is my goddaughter, but she, in her left hand, is holding a prototype of the actual filter wheel. She did have clean hands before she held it, I did make sure. And then the Eyes on Mars filter wheel on the right. So you can see the difference in scale, but the science and the excitement is still the exact same. So I was really happy to be involved in all of these events on top of distributing across the UK. Okay, so feedback. For anyone that does public engagement and outreach, evaluation and feedback are kind of words that cloud over us. We have to really think about these when we're creating projects. We have to do the evaluation. So we do send feedback forms for all the students to do. So we have a before the activity and after the activity, but it's very difficult to encourage them to do this. Some students just don't want to, some schools forget, and that's completely fine. So we have some feedback from students, but it's not representative of the numbers that we've reached. But in general, the enjoyment is there. So kind of over 80% of students that do the activity enjoy the activity. So we're very happy with this. Obviously, we can't reach all children. That would be ideal. I don't know of a project that's managed to get 100% enjoyment, but over 80% I'm very happy with. And then, has your opinion of scientists changed? And about a third of students said yes, which is really, really good, because I want to get away from this image that scientists are old people with crazy hair and a beard in a lab coat. So a third of students are going away from that. Now, this doesn't include in this, has your opinion changed? A lot of students say they loved the idea of being a scientist before. So no does include some positive feedback as well. But then there are some kind of longer bits of feedback. So has your opinion of scientists changed? There's a few little snapshots of some of the feedback we've had. I'll let you read over these, but some of the highlighted ones for me: not all scientists do the same thing. This is fantastic. We want to get away from that area, away from that opinion that all scientists just do one thing and it's being in a lab coat in a laboratory. Two that I feel like were quite personal to me in a good and a bad way. They're not all old. Fantastic. That's good for me. Now I know that university students are professional. Okay, I'm glad that I'm coming across as a professional, but I'm very sad that university students before that were being seen as not professional. And then finally, I used to think you needed to be clever to be a scientist, but you don't. And this is really what it's all about for me. You don't have to be the cleverest in the class. You don't have to be hyper intelligent to be able to be a scientist. If you're passionate about it, you can be a scientist. So I was really pleased with that. The next slide's quite heavy and there's a lot of information on here, so I'll let you just kind of browse over it. But here's a few of the answers that we got from What Did You Learn? I mean, if I put them all on, we'd be here for the whole talk, just reading through them. But there are lots of different areas covered here. How to cut carefully. This is something that we didn't think about when we did this proposal. And this is something that has been changed by COVID as well. Having spoken to a lot of the teachers and the demonstrators, they've said that since COVID, a lot of young people really struggle with their cognitive skills. So like cutting and sticking, they've really struggled with because they've not had that experience of doing it when they've been working from home. So being able to cut carefully might be something that's seen as obvious, but to be able to develop this skill is a really good thing. So that was a highlight of something that's come out of this project that we were not expecting at all. So really pleased with that. The UK is doing space stuff. Fantastic. The UK has its own space agency, and I'm hoping that most of you in here and online know that the UK has its own space agency, but lots of these kids don't. A lot of these kids have never heard of the European Space Agency, the agency that is doing Rosalind Franklin. So being able to say that not only are we doing it in Europe, but we're doing it in the UK is a real take-home message we want to kind of hammer in. So that's fantastic. Filter wheels can give you different information. That's amazing. That's the whole idea of this project. We're using these filter wheels to do fantastic, different, intuitive science on the surface of Mars. So it's good that they're able to take this home and talk about this. And then finally, this is my favorite quote ever from the whole project that I want to get on a t-shirt. You don't have to see the world in one way. You can use a filter wheel. I'm going to petition that to be the PanCam official motto. I think it's fantastic. I absolutely love it. So the feedback has just been overwhelmingly positive. There are lots of quotes that I could have put in, but these are a few of my favorites. So this has kind of been the success in terms of what's been delivered to students and young people across the UK. But personally, there's been really good successes as well. So Eyes on Mars was awarded the Project Award for the Centre for Planetary Sciences Outreach and Engagement Awards in 2023. And I was also awarded the Individual Award because of my contribution to this project. And then I was also awarded the Public Engagement and Outreach Award at the Mullard Space Science Laboratory's Department Awards in 2022 as well. So personally, I've been able to benefit by getting these awards, which is not what I do it for, but it's an icing on the cake. And it's really nice to have this recognition for the project as well. So what lessons have I learned from doing this project? I've had funding for over 2 years now, and there's been bumps on the way, but I've learned a lot from doing it. So the main thing is they have to be very flexible. We can't predict influences that might impact the project, and this includes geopolitics. The main thing being the unfortunate war going on in Ukraine. I never could have predicted that was going to happen. I never could have predicted the impact that was going to have on our social media campaign. But we adapted and we changed the kind of focus of the project, not being as much on social media, but being more on the delivery of the resources. And then COVID as well. Initially, when we made prototype 1 of the filter wheel, we used cardboard because we thought it'd be a better, sturdier material to use as the filter wheel. But because of COVID, young people's cutting skills wasn't as good, and it was taking a long, long time to cut the cardboard. So we decided then to just move to paper or card. So we had to kind of change it based on the skills and abilities of young people across the UK. And this has all been based on lots of feedback we've had from teachers, where we've been doing kind of practice runs in schools around Surrey. It has been a very large workload alongside studying for my PhD. My supervisor in the audience is nodding. I didn't predict this. It's been a lot for one person to do. I have really, really enjoyed it. But if I did it again, I would maybe have more PhD students to do it with me, more support. I would distribute work better. I think perhaps I just like to make sure it's done myself. But I think I'll be better at distributing the workload. But then the other side of this is that I've learned a whole multitude of new skills. So social media, scheduling and planning and evaluation of social media is something that I had no experience in before. I wouldn't say I'm very experienced in it now, but it's something that I've kind of learned along the way. Planning, evaluation methods, and these are all things that I was expecting to have to develop, but I think the way I've developed them has been really rewarding for myself, and I can apply this to areas of my PhD and areas of my life as well. Okay, so what is next for Eyes on Mars? So there's roughly about 6 months of funding left, and this is because I'm due to finish my PhD in the next few months. So with this about 6 months left, we have got about 70 resource packs left to distribute. So we've distributed over 150 so far, and we've got a few left over. So we're going to be pushing those a lot for Mars Day, which is happening early March, and then pushing them to schools as well. So they will all go, because at the moment my desk is full of cellophane and stickers. So the desk will be free. But when I leave, the legacy will continue. So I don't want this to kind of be, it only happens when someone's there funding it. The legacy of this project will continue. So the website will stay up, the social media channels will stay up. And rather than having myself email all of these digital copies to teachers across the UK, they'll all be uploaded for people to readily download. So people can continue doing the project. We just won't be able to send them the cellophane and the split pins and so on. But people can still get involved even after the project ends this year. So to summarise, Eyes on Mars has been providing free resources for schools and youth groups across the UK, and digitally we've also distributed resources worldwide. So a lot of the members of the PanCam team are international, and they've got these resources to distribute to young people in their respective countries. And a take-home message from me is that running a public engagement project is something that's not part of my PhD. It's something that I've been doing in my own time, and it's been so valuable, so rewarding. I've loved every single second of it, and I'm really proud of the project. Now, it's been a multitude of people that have helped with this project, so particularly the Royal Astronomical Society and STFC for their support, and then Ovarian Cancer Action, STEM Learning, ESRO, and then tons of names on there. And every person on that list has helped more than they probably think in helping this project be successful. So I'm really proud of Eyes on Mars. If you're in the room, then feel free to take some of the stickers and postcards online. If you are interested, drop me an email. I've put it at the bottom there, and I can send resources out to you. But yeah, I'm really looking forward to hearing your questions, and I hope you enjoyed hearing about my project. Thank you very much.
Testing. Hello. Okay, hold up for a second. All right, well, thank you so much, Catherine. We want to take questions. We're checking on this mic right now, and we definitely have plenty of time. I have some questions online for you as well. I do want to know, any deal with Quality Street?
That would be amazing. I don't think it'd be very good for my diet, but it would be great.
or the health of the children as well, but
Yeah.
I'm sure they would appreciate chocolate sometimes.
Yeah,
Okay.
perhaps I should get in touch with them and let them know.
So you moved on from Quality Street as a prototype, and then you
Yes.
cellophane.
Yeah, so we just bulk ordered tons of coloured cellophane to then distribute, but no. Quality Street, the issue is they got a bit sticky as well if there was chocolate left on them.
Yeah, really, I like how you showed that there's kind of a learning curve even for yourself. Doing education outreach, which is also what I do, going from cardboard to cardstock perhaps. So were the circles already cut out, or do they have to cut circles out in the card?
They have to cut them out the card. Yes.
It is hard.
Yes.
I can understand that,
So
yeah.
about the first 20 minutes is the children cutting out the card, because you can see that it's circles within circles, and having to cut a circle without cutting it from the edge is something that a lot of the time they haven't thought about how to do that. So in the instructional video, we give some kind of tips and tricks of how to cut a circle inside a circle. But yeah, a lot of time is spent doing that. And it takes some of them, it takes quite a lot of time to be able to do that. So yeah, that's why we moved from cardboard to just card.
Okay, I think the mic is working. Wonderful.
Fantastic.
Anyone have any questions? Please raise your hand.
Thank you, Tony, guys. Thank you very much for your talk. Really interesting. I just wondered if you could perhaps expand a little on how someone who was not in the top set for physics finds herself working on the next rover mission to Mars.
That's a really good question. I'll just repeat it in case those online didn't hear. So it was, how does someone that wasn't in top set science find themselves working on rovers on Mars? I think from a young age, I've always really been passionate about space. I'm a huge Doctor Who fan, and that is really what led me to want to do space. But being at school, it did put me down quite a lot to think I wasn't clever enough to do science. So I just focused on what I really enjoyed, which was geography. So I mentioned earlier, I did volcanoes and earthquakes, so I did earth sciences at university. And it actually was my undergraduate lecturer, Dr. Jessica Johnson, who had a conversation with me, and I was saying, oh, I'm finding this interesting, but I don't feel like I've kind of found my niche yet. And she said, okay, well, you interested in volcanoes, aren't you? I said, yeah. She said, well, why don't you do volcanoes on Mars? And I said, I can't do that. I've not done space. Like, I haven't done astrophysics. I'm not qualified. And she said, you know all about Earth volcanoes. It's just a different planet. So just apply yourself to do that. And that was what kind of really kickstarted me into doing space and into doing Mars. So it was from an Earth science perspective, but I went into doing volcanoes and loved it. So I then applied to do a master's in planetary sciences after I finished university, and unfortunately that was in COVID, but really enjoyed that. And in between this as well, having realised that space was something I wanted to do, I was probably quite annoying to a lot of people, but I was ringing people up and saying, can I come and do some work experience with you? I want to get some experience, some placement. Colin Forsyth at the Mullard Space Science Laboratory picked up, probably regretted it, but picked up his phone, and I said, please, can I come and work with you? And he said, we'll see what I can do. And I managed to do 2 summer placements at MSSL. It was doing Earth. It was before I officially moved to Mars, but I loved it. And I really loved research. I've always enjoyed kind of doing my own research project and doing something in a lot of detail and continuing learning. So loved the idea of research, loved doing the masters, and the idea of doing a PhD is something that I've always wanted to do, but again, was always a bit apprehensive whether I was going to be clever enough to do it. But thankfully, Professor Andrew Coates, who's in the audience, took me on to do a PhD, well, nearly 4 years ago, and I've loved every second of it. And I think the really unique thing about the UK is that it's not just at MSSL, at UCL, it's institutes across the UK. We have so much involvement in missions, which I don't think is kind of shouted about enough. And this is not just Mars missions, but kind of astrophysics, Earth observation. So going to an institute, you get to be involved in these missions, which is insane. So I was being able to be involved in the science meetings for the Rosalind Franklin rover, which is crazy. Being able to go to the European Space Agency is crazy. So I think it's just being from following what I've been interested in, and even if I doubted myself a little bit, just still kind of persevering and saying, well, I love doing this. And if you love doing a day job, then you can't go wrong, really.
Thank you.
That's all right.
Yeah, brilliant what you've done. This project is focused sort of on one scientific concept around filters and things.
Yeah.
Just made me wonder whether there's an opportunity for, there's got to be so many concepts like that to do with the project, whether others could be developed in the same sort of way to help schools learn about many other concepts.
Yeah, definitely. I mean, for Rosalind Franklin in particular, I mean, there are 7 instruments and we've just focused on one. And the UK has just announced that we're replacing the Russian instrument, which is called ENFIS, which is going to sit right underneath, which is a spectrometer. And that's being led by Aberystwyth University. So I've chatted a little bit to the team there about whether they can develop something for ENFIS, which would be fantastic. But there is so much potential. At MSSL, we do things for other missions. So Gaia, which is a galaxy explorer. I'm not going to talk about it anymore because I'll get it wrong. But we have an activity where just using a CD and a piece of paper, you can create your own spectroscope where you look at a light and you can see the color spectrum. And that's just using a CD and a bit of paper. So there are so many potential opportunities to do it. It just needs someone to sit down and imagine it, which is something I hope to continue.
Yes, after you've got your children completely hooked on space and wanting more, do you have links to the actual project and maybe stuff that's written at an intermediate level as they grow up and go through school to stay in touch with this project that they've been connected to?
Yes, so on our website, we have a resources page that has a link of resources across the UK and the European Space Agency that talk about the rover and talk about other different science aspects. In terms of Eyes on Mars, we haven't done anything for afterwards. We hope that they kind of revisit it. We've had repeat customers, but repeat usage from schools as well. So they continue it. But reaching the older ages is something we personally haven't done because we felt like there's a lot more done for kind of GCSE age. So that's why we targeted our age group. But there are other resources available.
In the room. Online, we have someone asking about polarizing filters, and did you have any ideas to working that into your filter wheel, or do they need those on the Mars rover?
I mean, I did think about it, but putting a polarized lens would be fantastic. But the reason we didn't kind of go down that route was cost. We wanted to kind of keep everything as cheap as possible so we could be able to provide more. And also that when this project ends, it wouldn't be too expensive for groups to be able to do themselves. So we didn't. I believe, I'm looking at Andrew on the camera itself, is there polarized lenses? Not on this one, okay. Okay, so that's a new Mars mission coming soon for polarized lenses.
To know exactly. And I see in your image that you're sharing on the screen that they had cut circles and squares, so at least they didn't have to do it.
Yes, exactly. Squares are a lot easier to cut than circles.
Cellophane, yeah. Again, if there's any other questions in the room, please raise your hand. I have one question online who's asking about dust storms.
Yes.
I'm not sure, they haven't rephrased it yet, but there are weather conditions that might need to occur for a Saharan dust storm to become present further north. I'm not sure if that's related to anything you said in the beginning about Mars. I know there are dust storms on Mars that happen.
Yes. If it's about Mars dust storms, I can answer it. If it's about Earth dust storms, I'm not sure. But
They're asking in relation to global warming, temperature rise, but
okay.
I'm
not an Earth expert. So I guess with global warming, the extremes on Earth become more extremes. There could be more dust storms. On Mars, though, which is what I can talk about. Very briefly, what I research is global dust storms on Mars. So every Mars year, there is a dust season, like we have hurricane season, and there are regional dust storms. Every now and again, we don't know why some years they happen, some they don't. These storms grow and merge into a global event. So the entire surface is one storm. And that's what I'm studying. So that's an area of ongoing research as to why some years they happen and some they don't. I'm hoping there'll be another one soon, so I can do some more research.
Wonderful. Thank you. Thank you for answering that. And then a question from a GCSE student.
Fantastic.
Online. Their name is Kang Lee, and they have a strong interest in a career in astronomy and wonder if you have any suggestions for any astronomy-related projects that they might be able to organize at their school.
Fantastic. For GCSE age, I would say you could do Eyes on Mars. It might be a bit below your level, but I'll happily send out resources to you anyway. But for GCSE age, there are tons of stuff. So the STEM Ambassador website is where I would go to first, and they have basically a catalogue of resources that you can download. The Gaia spectroscope activity is a really good one to do. So you can talk about the Gaia mission and galaxies. I believe that is Cambridge University that organised that, but I might be mistaken. And I think especially for GCSE age, if you email around, depending on where you are based in the country, email around and see if there are any students or professors or lecturers that would come in and talk to you and talk about what they do. So I think that would be really good as well for an astronomy club.
Yeah, exactly. Start an after-school astronomy/space club.
I'd join.
You can even you can even contact us at outreach@res.az.uk if you have any questions about how to do that.
I loved your talk.
Thank you.
If this perhaps beyond what you're here to talk about, but what dangers will the Rosalind Franklin robot meet on Mars? Dust storms have been mentioned.
So
Volcanoes, all these things.
So earthquakes, Marsquakes, we thankfully haven't detected any that are significant to impact our operations. So the InSight lander was there to detect Marsquakes, and it didn't detect any ones that were too big. The volcanoes are all dormant, thankfully, so don't have to worry about a volcanic eruption. But dust storms is a big one. So the launch window is roughly every 2 years on Earth, and at the moment there's a bit of talk happening because when we launch, touch wood, in 2028, we'll be arriving in dust season. So the last thing we want to do is send a multi-million-pound instrument through a dust cloud onto the surface because it will just damage it. So we might stay in orbit for a little bit, we might not. We'll wait and see. But dust really is something that we have to think about. So the dust is actually slightly electrostatic, so it sticks to the rover panels itself because it clings on. And unfortunately, if that covers the solar panels, then that is rover's done, which is why we have nuclear batteries as well as solar panels at the moment. The Opportunity rover died in 2018 after the last global dust storm because it just covered the panels. But PanCam, we are kind of ready for dust. So in the cameras, I don't know, it might not be in the photograph, but there's a tiny little hole and we can blow air out of this hole from the inside to blow dust out, basically, to stop dust buildup in our lenses. So we can avoid any scratching because we don't want to have scratched images. So that's a big hazard on Mars. And then I think the biggest hazard really is just landing there safely. It's called the kind of 7 minutes of doom or the 7 minutes of terror, which is where we go from orbit down to the surface. So there's so much preparation, simulations, models done to prepare for that. So that's kind of the biggest issue we're facing. But it's tried and tested. We've had lots of successful, a few unsuccessful missions, but from all of them you learn stuff to reduce the risk.
This brings up sort of the question coming up with Mars sample return, and kind of the current state of the economy and
yes,
and research funds. But Gideon asks, when you get to be super famous, will you be involving someone quite close to you in producing the Martian returns? I don't know if this is someone you know.
I think it might be someone I know. Will I be involved in the Mars sample return? I would love to be involved in Mars sample return. I feel I can't comment on Mars sample return because I don't feel up to date with the current state of the economy and whether it's going, whether it's not. The NASA budget is very tight, but hopefully it will go. I mean, the Perseverance rover, for those that don't know, is currently dropping sample tubes on the surface of Mars. And the Mars sample return concept is for another rover to go collect these tubes, launch back from Mars and bring them to the surface. And I've visited quite a few facilities across the UK that have got areas ready for the samples to come back and we can do testing on them, which would be great. Yeah, I would really love to be involved in it. But I think it's kind of mid-2030s is the current estimate. We shall see, yeah.
I don't think you're ever too old to do a TikTok.
If there are any social media people that could teach me to TikTok, I feel like I'm aging myself by saying, teach me to TikTok. But yeah, it's daunting.
Questions for our speaker today? Waiting as long as I can. Thank you so much, Catherine. Did you see the question? Oh, we do. Excellent. Okay. We have time.
Most of the successful landings only seem to be in American. Are you able to will this mission be able to take advantage of the American expertise on successful landing?
Yes, yeah. So the really good thing about space is that in general, most space agencies across the world are really into collaboration and sharing ideas and sharing concepts. So one of the reasons that we had to suspend the mission was because it was a Russian rocket that was going to launch the rover. So America have kindly said that they will launch Rosalind Franklin, which is really good. So they are helping us with that and also helping the technology sharing. So we're not using a helicopter, I don't think, like Perseverance. So we're going to be using a parachute. So it's slightly different tech, but the helicopter's only been used once for Perseverance, whereas parachutes have been used quite a few times. So yeah, so it's all about sharing the technology and still doing it in a European way, but with help from NASA.
Yeah, I would think, well, I guess, I don't know more about if Andrew has any more information about the state of ExoMars and the launch, but I imagine with putting it on another rocket, not using Roskosmos or Soyuz, they'd have to like redesign a fairing to hold it, I'm guessing now, which is, yeah, a lot of Andrew's nodding his head. Yeah.
A fair amount of redesign of the mission itself and the landing engines for the lander will actually come from the US, but the lander itself, again, will be built in the UK at Airbus and Stevenage. So another good thing for, as Catherine was saying about the rover itself. But yeah, getting the landing engines, those will be a NASA component of the launch itself and the radioactive heating units. So those are the things which we're waiting for NASA to fully approve. And everybody's very confident that this will happen. So we're hoping very soon, after political issues, that will be done. But exciting mission.
Yes.
Even going in 2028, arriving 2030.
Yes.
Fabulous mission, yeah.
2028.
Well,
2030, yeah.
let's finish on that very positive note for for Rosalind Franklin in 2028, 2030.
Yeah.
Thank you so much, Catherine, for your talk. Thank you, everyone, for being here.
Thank you.
And our librarian would be happy to welcome you upstairs if you'd like to make your way up to the first floor. It's up to you. Thank you, everyone, for being here and visiting us at the Royal Astronomical Society. Thank you, Sam.